Hi, so my name is AJ Shastri, and my group has decided to develop a sanitation product that utilizes UV light technology. So our need statement overall is to create a more convenient product for the customer while also being more cost effective and also eliminating the use of water and soap, which is a great need for conservation. And we have conducted research on similar products and have found that those other products are either too expensive or have their own cons, which we'll go more in depth into when we get to the analysis of alternatives. So overall, our goal is to create an affordable sanitation product that utilizes UV light technology. So first of all, when it comes to satisfying the need for more convenience, personally, when I'm doing dishes, I don't like cleaning cups just because if I'm grabbing what's usually already a dirty sponge and reaching my entire hand into it, that's pretty gross. So we want to eliminate sponges and other scrubbing products such as that, as our product aims to just focus on rinsing the product as we focusing on cups and then using our UV light technology to sanitize the cup. And our product is also more convenient than a traditional dishwasher and more cost effective as dishwashers take a long time to run, obviously, and also they're really expensive. And our product aims to be more affordable and focus on a better way to clean cups quick. And also in comparison to a regular dishwasher, it is small frame and it's way lighter in weight. And other need we aim to satisfy is conservation. So obviously, a dishwasher uses gallons and gallons of water, and obviously, our product doesn't eliminate the need for water as it rinses out the product still, but that's still way less water in comparison to hand washing a dish or putting in a dishwasher. And it also eliminates the need for soap when it comes to cleaning cups. And also, when I'm personally doing dishes, I've noticed that the entire top rack of the dishwasher is typically filled with just cups and mugs. So our product is going to eliminate the cycles that are needed for the dishwasher. Well, it may not like eliminate the need for a dishwasher overall or hand washing overall. It eliminates the need to run more and more cycles every single day, thus saving gallons of water. So overall, our product has local environmental benefits. As I just stated, it saves gallons of water. And when it comes to personal benefits, it's more convenient, it's quicker, it's less gross.
Hello, my name is and from Team 7, and now I'm going to talk about analysis of alternatives. So, what's the problem? What we're trying to solve is that we're trying to make a cup cleaning process faster, easier, and more hygienic without heavily relying on soap, water, or sponges especially for students and for some people who live where the dishes weren't available. And what alternatives we have for this problem is that uh okay, we had three alternatives and I'm gonna name it as like A and B, C. So for A we have a UV light cleaning device, and for B we have steam mini sterilizer, and for the device C we have electrolyzed water sprayer. And so what's the advantage and disadvantage of each device? For device A, alternative A, its advantages, it's fast, it's portable, it's cheap, and disadvantages, if you use it for a long time, continuously, it may have a heating problem, as so much devices have that problem, as same as those. For device B, sanitizes very well and it's portable, but the disadvantages of this is it's bulkier, even though we say it's mini, it's bulkier compared to the other alternatives, and it's slower to warm up since it's basically like a mini version of a dishwasher. So it's gonna be slower to warm up, and it's gonna need water power, which results which would be more expensive to the alter compared to the other alternatives. And device C is it's safe, it's consumable, cheap consumable. It's just basically a salt water. It's gonna work on any shape because you're gonna spray it how you want it. And disadvantage of this is the depending on your like a cup or a bowl material, it can make it corrode. Also, it depends on the mixture of the spray also. So what method we use to choose the alternative from the rest is that we just made a table and we put the requirements, the best aspect of the product in a first row: affordability, portability, ease of usage, and reliance on water and soap water or soap, etc. And these are the results. So that leads us to the device A, which doesn't really heavily rely on water. It's like doesn't really rely on water actually. So, and it's portable, it's easy to use, and it's actually very cheap compared to the other alternatives, which gives us the best result.
Hello, my name is Kenny Dana. I'm part of Team 7 and I'll be doing the concept of operations. Here is a basic overview of the product's function. First, we begin with a rinsed cup and the device plugged in. After that, we get our rinsed cup, we place it upside down on top of the device. We wait a few minutes and we're returned with a clean cup. Now you might be wondering, how do we determine the runtime? So to determine the runtime, we need to understand a few variables. First of which is intensity. Intensity is equal to power divided by 4 pi times r squared. So that P equals power and that R is equal to distance from the lamp in the surface of the cup. As you can see, it's directly proportional to power, and we want to make sure that that distance is reduced as much as possible to make sure our intensity is as much as possible. So we want that intensity to be high. Now we're moving on to power. So power is essentially the power that is delivered by the UV lights. This can range depending on your application, but for our application, it can be taken as 10 to 50 milliwatts. The next variable is dosage. So dosage is interesting because it depends on what you're targeting. So if you're targeting bacteria such as E. coli, then your dosage will be about 6 to 10 joules per meter squared. However, if you're targeting something such as fungi, then your dosage will increase more than to 100 joules per meter squared. So now we can calculate our time, which is equal to our dosage divided by intensity. And now you can see why we want that distance between the cup and the light to be as small as possible, because we want our intensity to increase and reduce our time. And yeah, that's how we calculate our runtime. And thank you.
Hello, my name is Seth Lishner, and I am an aerospace engineering student. My part of our project is the system requirements. The first system requirement for our product is that the UV light shall achieve a 99% bacterial reduction per use. This is a key criteria for our product, as it is going to be targeted towards homes with families that are on the go and need a quick way to clean their glasses. The 99% reduction for bacteria will ensure that our product is not only safe, but just as good as all other alternatives. This will be done by using proven UV light technology and ensures the main function for our product. This must be proven in the prototype phase, as this is the key function for our product. Our next system requirement is the device must be able to operate in a standard household outlet. This is typically 120 volts. This will clearly define the power input needed for our product at 120 volts. This also ensures that the product is usable in regular household circumstances, as again, our key audience are the everyday household user. This aligns with our home usage as it is what the product is designed for. This also will be implemented in the product design, as this is another key requirement for our system. Our final system requirement is that the cost per unit will be under $50. This will align with the price margin for our product being under $50. It ensures that our product is cheaper than other alternatives, but is also still profitable. This aligns with the affordability goal set forth in our initial design, and this will also be implemented in the product design as another main requirement for the system. Affordability is key when designing a product that will be used in a household. In conclusion, our UV light shall achieve a 99% bacterial reduction per use. The device must be able to operate in a standard household outlet of 120 volts, and the cost per unit will be under $50. Thank you.
Hello, my name is Gael Peralta Uribe, and I'll be presenting the functional analysis and the SWOT analysis of our UV cleaning device. The dish cleaning process starts by first receiving a user input. This will then turn on the UV lights, which will commence the disinfecting process. And after running for a certain amount of time, it will then turn off the device. One of the benefits of having such a simple device is that it's extremely cheap to make. The cost of the materials are not that expensive, and due to the small frame, the overall manufacturing cost is extremely cheap, especially compared to traditional dishwashers. And also due to a small frame, you can take our device anywhere you like. All you need is a power outlet. However, we do have some weaknesses in our team. We do not have access to any manufacturing plants, so we would have to get in contact with one of them in order to manufacture our product. We also have no connections with the retail companies, and there's not a lot of promotion for this type of product. You don't see like in the retail companies, so trying to justify why we belong in retail companies will be a great hurdle for us. However, we can use this as an opportunity. We do genuinely believe there's a demand for our product. However, there's not a lot of goods fulfilling that demand, so we can come in to fill in that gap in the market. Also, with the rise of health consciousness in the public, we can use that for our marketing campaign in order to promote our product as well. However, there are some threats for our device. There's been a rise in production costs, especially due to like tariffs and the weakening U.S. economy. Also, mass layoffs and people struggling to find a job are not helping, since people are not willing to spend money on a device they may deem unnecessary. Thank you.